Alright, it's about time, so we'll go ahead and get started. Hello everyone. Thank you for joining me early on the second day of CodeStock. My name is Jeremy Fairbank, and today we're going to talk about Webpack. If you've not heard of Webpack, it's a front-end build tool for bundling together your JavaScript assets to create one bundle file served to the browser. If you've heard a little bit about it, you probably know it's notorious for being very complex, very configurable. So what we're going to do today is walk through building up some simple examples to get a pretty complex bundle going. We'll see some demos along the way. So hopefully by the end of this talk, you'll have a good idea of what Webpack is and how you might be able to use it for bundling your JavaScript files. So briefly about me, I work for a company called CGAMP, formerly known as Push Agency. And we are a completely remote team focused on design and front-end development. In addition to being an agency, we also have our own product called Simply Built, which is just a website builder and editor, along with hosting and domain management. And I have free t-shirts here if you would like one at the end of the talk. So, since we're talking about Webpack, we're also talking about JavaScript, and I want to start off by talking about the fact that JavaScript has been slowly evolving and growing over the past several years. What once was a language primarily for the browser has grown into the server, as well as robots and the Internet of Things. And so JavaScript has become a very versatile and useful language. But historically, it has had a problem with dealing with modular code and how to have explicit dependencies. If we look at other languages like C#, Java, Ruby, Haskell, they all have some sort of affordance for importing dependencies, declaring what this particular file is going to depend on and use. Now, historically in JavaScript, this has been a problem because we would just have to throw a bunch of script tags in our HTML document. We would have our third-party dependencies and then our application code. And so this creates a lot of implicit dependencies. So when we get in our actual application code, we have all these global objects that we're depending upon, and we don't immediately know when we open up a file what are the dependencies that I use in this particular application. Now, the modular issue isn't the only issue. Another problem, obviously, is when we have a ton of script tags, and that's a lot of resources that we're forcing the browser to download separately, and that creates a lot of latency and other performance issues. So thankfully, over the past few years, we have had explicit options pop up in JavaScript. We've had the AMD, asynchronous modules, with require.js, and that actually could bundle up files for us as well. And then in the node, the server realm, we have the common.js spec for requiring modules explicitly in a synchronous manner. And then within the past couple of years, we've had the ES 2015 spec become standardized, which actually gave us a real syntax for importing and exporting dependencies. But this still poses a problem. All these different syntaxes that we have available, they're still, excluding require.js, aren't directly consumable by the browser yet. So we have to have a way of being able to write modular code in JavaScript, but still be able to consume that in the browser. And so that's where Webpack comes in. Webpack, as its tagline suggests, is a module bundler. So it takes modular JavaScript code and can bundle it together for something that the browser can consume. So at a high level, we can take all these different syntaxes for modules, throw them into Webpack, and it can produce a bundled JavaScript file that the browser can then use. Now, Webpack does more than just this. In addition to bundling together some JavaScript files, it ends up being a very versatile tool and platform for lots of other things, especially pre-processing and including other assets, not just JavaScript. So thanks to Webpack, we can also write ES 2015 code, and we can pre-process that and bundle it for browsers that don't support some of the new features. We can also include CSS, HTML, and images in addition to JavaScript files, and we can bundle those as well. So returning to that implicit example we had before, I'm not going to dive too much into this, don't worry. We're going to mainly focus on our dependencies now. So we can use this ES6 syntax for importing our dependencies. Now we have them explicit. So what Webpack does, comes in, it reads your dependencies for your application, And then it takes that and it can build a dependency graph out of that. And that's what's so crucial and so powerful about Webpack, is that it can read your code and understand what your dependencies are and give you this dependency graph for bundling your files. So with that high-level overview underway, let's go ahead and start diving into Webpack itself. So to get started, Webpack is a Node module, so you will need to install Node. So you can visit nodejs.org. There's binaries for Unix systems, Linux, Mac OS X, and Windows. And then along with Node, you'll get the Node Package Manager. If you've not heard of that, it's essentially a package manager for Node, something like NuGet for .NET or pip for Python. So once you have that installed, you can then use npm from the command line to install Webpack itself. You use that G flag to say, I want to install this as a global binary. So once you have Webpack installed, then it's as simple as calling Webpack, providing it for the first argument, your entry file name, where your application starts, and then an output file name, which we'll call bundle.js. So we're going to look at a simple example through a lot of these Webpack configurations, and we'll see how we can use Webpack for that. So we'll look at the code more thoroughly in the code editor here. So right now we got nothing, because we need to build our bundle. So we're going to go in here, and this is the code we just saw on the slide, and I'll explain what's going on here. Basically, we're using CommonJS to require a few modules. Here I'm requiring left pad, and that's actually coming from npm, so that's going to be a third-party dependency. And then I've written a couple modules myself, a logging module and a math module. The math module just has an add and a multiply function. So I'm going to create an instance of my logger, and I'm just going to log out some string that lets me know what example we're running. And then I'm going to log out 29 in binary, and I'm going to use left pad for this so I can just force it to be 8 digits with zeros on the left. And then we'll do 40 plus 2 with my math add function and 10 times 2. So pretty straightforward example. And just to show you the modules I wrote for the math one, it's very straightforward. I'm just going to export this add function and export this multiply function. But notice we have this all in a modular fashion. We're declaring our dependencies up top here. So now we want to bundle this together so we have something the browser can use. So we're going to run that command, webpack, give it main.js, then a file name called bundle.js. We run that, and now we have some output. We see it's created bundle.js, it shows what modules were involved, and there we have the bundle.js file now. And we'll briefly look at that to show you what Webpack is doing with the code. So initially, Webpack has this function up here which kind of bootstraps everything, and it takes as an argument all of your modules. That includes your application and all of its dependencies, and that's going to be an array. And then Webpack's going to define this function called Webpack require, which is going to replace all of our CommonJS require statements we had in our source code. So we'll go down now, and Webpack's basically just going to be able to load your modules and cache them. And down here, it's a little weird looking, but they're invoking with an array all of your modules. And the first item in there is going to be a function that contains your original application. Here's where we required left pad and our logger and math functions. But notice we've replaced require with Webpack require, and now it's taking numbers. And these numbers, they're just referring to indices into this module's array. So those are going to be your dependencies. If we go down and see number 1, that's just the source code for left pad that we got from npm. Going down further, there's our logger function, which I didn't really dive into. And then finally, number 3, there's our math module with our add and multiply function. Now, if we run this again, we see it works. There's our example string, there's 29 in binary, and then 40 plus 2 and 10 times 2. So we wrote all this in a modular fashion, but we were able to still bundle it together and then let the browser consume that and just use one file instead of multiple files. So returning now to Webpack, it would be nice though if we didn't have to keep rerunning from the command line Webpack, the file name, and then the output file name, especially when we want to add more configuration to it. That could get really tedious. So the conventional way to normally build with Webpack is to define a Webpack config file. And inside this, you're going to export with common.js module.exports an object that is your configuration for Webpack. And notice here, it's very similar to what we had at the command line. We have an entry property, which is the name of your application, where it all starts. Then we have an output object, and inside of that is a file name for what you want your bundle to be called. We just want it to be called bundle.js again in this example. And then just to show you that this works, we run a demo of it. Nothing right now. See, we have a Webpack config.js file. We open it up, and there we have the same stuff, the entry and the output file name. But now, all we need to run is Webpack by itself, and it generates the bundle file with the same modules. Just to show you, we opened up bundle.js, here's the same stuff we saw before, the bootstrapping code, our actual code, and then when we run it, it works. So now we can just create this configuration object, and we can just rerun Webpack without having to remember all the arguments to it. So now that we've had sort of this basis to work off of, we're going to keep working through examples and adding more to this configuration object and seeing how we can do more complex things with Webpack. So I mentioned earlier, Webpack can be a platform for pre-processing files, including other file types. And these are called module loaders. And so that's just a different way of saying these are pre-processed steps, ways for you to pre-process your code before it actually gets bundled into a JavaScript file for the browser. So a perfect example for this would be to look at pre-processing ES 2015 code via Babel. So at a high level, our pipeline is going to look something like this. So first off, we'll go ahead and rewrite those common.js requires we had before, and we'll use the ES 2015 import syntax. And what's going to happen is, before Babel actually, before Webpack actually bundles it, it's going to use Babel to pre-process that to the equivalent ES5 code. And so then it'll become the normal common.js statements that Webpack understands. So once it does that, then it can bundle it all together. Now to get Babel sort of set up to work with Webpack, you'll have to install a few dependencies. You'll have to use npm again, and we'll use this save dev flag, which is just saying I want to save these as development dependencies, not as full dependencies of my application, because we're just using this for building. We'll move the Babel loader, and this is going to be the tool you need that bridges the gap between Webpack and Babel. To install Babel itself, we use Babel core, which has all the core functionality that it needs to tokenize and parse the JavaScript. And then finally, Babel preset ES 2015. And that just is a bunch of plugins put together to help Babel know how to parse the ES 2015 code and make the equivalent ES5 code. And then finally, once all that's installed, you just got to configure Babel as well with the Babel RC file. And that's just some JSON syntax with one property presets. And that's set to the ES 2015 that we want to use. So then we just got to make sure Webpack knows about all this. So we're going to add a module property now to the Webpack config. And inside of that, it's going to have a loaders array. So since it's an array, that's going to suggest we could use multiple loaders. So we can do things besides just processing ES 2015 code. So inside this array, we'll have objects. And they'll typically have two properties, usually test and loader. This one's going to have 3. But test is just going to be a regular expression. And that's just going to test every file name, every dependency that Webpack can encounter. And in this case, we're using .js. We're saying if it's a JavaScript file, then go ahead and process it. We'll add another property called exclude, which is just going to say don't worry about modifying the node modules folder, all of our third-party dependencies. And then finally, the loader property, we're just going to say use the Babel loader in this case, and it'll automatically append -loader to that. So looking at the demo of this, we'll open up the Webpack config, same one we saw before with now our module loaders. And we're going to use the same example we've seen before when we log out some numbers. So we'll run Webpack. It's created the bundle file now. And just to show you that it did get pre-processed with ES 2015 by Babel, we'll scroll down to our code, and notice now it looks a little different. We've got a lot more code here, but this is the equivalent code in ES5 that was transformed by Babel. And then just to verify that it all works, we'll run it. And there we go. So now we got the ES 2015 code with the import syntax that Chrome doesn't support yet, now working and running thanks to Webpack and Babel. So now let's keep building upon this and add in some more features. So one of the other things you might have noticed when we looked at this particular example, my two modules that I wrote, I'm using a relative path here. Modules, log, modules, math. It would be nice if I could avoid having to always put a relative path in here, especially if I wanted to move things around. So that's something we can also do with Webpack. So we're going to add another option called resolve to Webpack. And if you are familiar with some other languages where there's this concept of load paths, it's essentially what we're doing here. We're saying, if I give you a module name, here's some places you can look to find it. And so that's what we're going to do with resolve here. We're going to give it root, saying here are some root paths that you can search in. And so I'm going to give it my modules directory. And it has to be an absolute path, so the other thing I have to make sure to do is I import the path module, and this is all inside Node. This isn't code that gets run in the browser, remember. So that's just a standard library in Node. And I can call its join method with the magic constant dir, which is the current directory. And then that with modules. So that's just going to give me back an absolute path to my modules folder, all my custom written modules. And then what that allows me to do is I can return here now and I can get rid of the relative paths, and I can just say import create logger from log and import all as math from math. And so that's really convenient, especially if I need to move some files around. I don't have to keep track of all these relative paths. But that does bring a good point up, and I've mentioned this a little briefly about importing LeftPad, and I'm saying that's coming from npm. So what's that all about? How is Webpack able to consume that from npm, which we know is the Node package manager? Well, it turns out Webpack is actually already configured to automatically resolve to Node modules. And it does it in a recursive manner, no matter how deep in your application structure you are. So what this really means then is that we can use npm as the package manager for even our front-end dependencies. It's not just for Node. So this is pretty powerful and useful. So I can install LeftPad by npm, and I can import it in my application. In our earlier example, I can actually import jQuery, React, Moment, and other libraries via npm, and then consume them via Webpack, thanks to this nice understanding that Webpack has of the Node modules folder, which comes from npm. So another thing you might want to use Webpack for, and could be very useful, is the idea of multiple bundles. So you may not necessarily be building a single-page application. You may not need one bundle file only. You might have an ASP.NET application or a Rails application where you have something, multiple pages rendered on the server, but they need different JavaScript assets. So you need multiple bundles. In this case, I have a main.html and a numbers.html, two different bundles. So one idea to handle this is we could create two separate configurations, Webpack main and Webpack numbers, and use each of those to create separate bundles. But as we add more and more pages to our application, that could be very laborious and tiring. So ideally, we want a better way to handle creating multiple bundles. Well, it turns out we can actually just use one Webpack configuration to generate multiple bundles. So I can feed in my main.js and my numbers.js, but I can make sure it doesn't bundle it all together in one. Instead, I can make two separate bundles. And so to do that, we can add another configuration object to Webpack. Or in fact, this time we're going to modify one a little. So before, remember, our entry property used to be just a string, main.js. I can actually put an object there instead. And what that allows me to do is to specify multiple entry points. And the keys I use here, main and numbers, those are arbitrary. You can name them whatever you want. Typically, we'll probably just have them be the same as the file name. So I have a main.js file that I want to feed in, and a numbers.js file that I want to feed in. So I can feed those both into these separate entries, And then I can modify the output file name. And I can include this special syntax that Webpack understands with the brackets. And I put name in there. And what that's saying is, when you process a bundle, look to see if it has a name property. In this case, that would be main for numbers. And then it would use that name to produce a bundle. So it's kind of like a template variable, inserting the name there. If we didn't do that, and we just had bundle.js there, then we would end up overriding one of the bundles. So to demo this and show you that it works, we'll look at the Webpack config, just what we had before, 2 entries, output file name with the name in brackets, and then we'll run Webpack. Notice now it says it created 2 files, main.bundle.js and numbers.bundle.js. Now just to show you what's going on in numbers, since that's a little different from our previous example, all I've done is I've created another module called array, and it just has a map and filter methods on it. I'm creating numbers 1 through 5. I'm going to log out the original numbers. Then I want to log out those numbers doubled, thanks to my array map function I created. And then I wanted to display those numbers that are greater than 3 by my filter. So I'm just using some arrow functions here from ES6. So we've created the bundled files. And now if we go and look, here's the main. And it works just as we've seen before. If we actually go look at the source, notice there's main.bundle.js. And then if we go to numbers, there's the original 1 through 5, there they are double, and there they are filtered, those that are greater than 3. But if we, again, view the page source, there's the numbers.bundle.js. So this works. It created 2 separate bundles for us, and they work in our static HTML. So now we've been doing a lot, building these bundles. Webpack is inserting some bootstrapping code. We're transpiling ES 2015 code. It's one file. What happens when we start to have bugs? How can we actually debug this code and make sense of any issues it might be having? And what do I mean by that? Well, let's look at this simple example above where I'm just taking that numbers array 1 through 5, and I'm going to loop over it with a for of loop from ES6. And you'll notice there's a bug here. I'm logging out n.toString, not toString. So up top's my original ES 2015 code. But when it gets transpiled, I'm going to get a wall of text. And if there's an error, which we're going to see there is an error with this toString call, it's going to be harder to know where my actual bug is. Not to mention that this is also all thrown into one file along with all of our other modules in the bundle. So the way we solve this is with something called source maps. You've probably heard of these before. They've been out for quite a while now. But the basic gist of a source map is we can take whatever code the browser has and has run. We take a map, and the browser can read that map, the code it ran, and then from that it can determine what the original source code was. And that way we can identify where the real bug is in our source code. So source maps have been around a long while. It'd be nice then if we could utilize source maps in our Webpack bundle. We can. So there are 2 different approaches. One approach is I can feed in my application and produce the bundle file and a map file, and then the browser can look for the map file if it needs to get back the source code for all of your modules. Another way is to inline it, which is typically what I prefer when I'm developing locally, and that's what we're going to look at a little. But it's going to take your application, produce the bundle, and then append the source map to it at the end. So now to get that working in Webpack, all we have to do is add one property called DevTool. And in this case, I'm going to provide it the string inline source map. And so there are certain strings that it expects to work. If I didn't provide inline, then it would produce a separate source map file. But I'm going to say just go ahead and append it to the bundle. And then the little hash symbol there, which looks kind of confusing, well, it's actually related to what pragma you want to use in the source map. And that's just something that really the browser is concerned with. So For all intents and purposes, you'll want to usually include that hash symbol so that the browser can know that there's a source map and parse it out. So now let's look at what happens when we don't and when we do have this dev tool enabled. So first off, we will go ahead and build the example that does not have source map enabled. So I'm going to run Webpack. Then we'll go to this example, which is our numbers example we had before. We doubled the numbers and then looked at numbers greater than 3. Notice it didn't actually show anything else. If we bring up DevTools here, we'll see that there was a bug. And if I try to find out where that bug is, it's going to throw me in the middle of some transpiled code in my bundle. So I'm not going to really know where the bug is. I might be able to spot it right here, but in larger applications, it's going to be hard to know where this bug actually is. This isn't very helpful. So now, if we apply the dev tool here, we'll go to the folder that has the example. And just to show you in the Webpack config, there's dev tool with inline source map. We'll run Webpack. It'll produce the bundle. And then to show you what this inline source map actually looks like, we'll go to the bottom, and it's just a big, long, base64 encoded URL. And so this isn't something you'd want to do in production, because it's going to generate very large files, but it's completely fine for local development. So now we'll run it. Again, we don't get the rest because we know there's a bug. But if I bring it up now, and I try to go to where the bug was, it's going to plot me in my array module. So not only did it take me back to my original source code, it actually took me to the module. It was a dependency of my actual application. I was able to go directly to where the error is happening. Right here, I misspelled push, and I've written push D. So now I know where the actual bug is, I can fix it. So source maps with Webpack are very powerful and useful. So we've been talking now about doing development with Webpack. And so let's take this now a step further and start to look at some of the really cool features that Webpack offers when it comes to development. So Webpack also has something called Webpack Dev Server. And what that is, as the name suggests, is a separate development server you can run in addition to your application. And the Webpack Dev Server will manage bundling all of your entry points and serving those files itself, just like a normal web server. But it does a little more than that. So at a high level, when you're on your browser, you visit your application locally, it requests the bundled file. Webpack Dev Server will bundle it if it needs to and then send it down, just like any old web server. But in the background, Webpack's going to be watching that dependency graph. Remember, Webpack analyzes your source code. It knows what dependencies you're using. So it's watching that dependency graph. And let's say I go in and I edit my log module. I haven't even touched my main business logic, my application code. I've just touched one of my dependencies, the log module. Webpack's going to notice that, though. And then it's going to notify the browser that something happened, something changed. And that's going to signal the browser to then refresh, download the new bundle, and have it served back to the browser. So to get Webpack Dev Server installed, as you might guess, it's installed by npm. We'll use the G flag because it's a global dependency again. And then we'll run Webpack Dev Server. And there's a few flags we can provide. In this case, I'm going to provide a host flag and say I want it on the normal localhost IP address. It defaults to port 8080 actually, but I provided that here just to show you you can choose whatever port you want to use. And then finally, this is the critical step to include, the inline flag. Sounds kind of weird, but what inline means is it's telling Webpack Dev Server to inline some additional runtime code into your bundle, which is fine because you're just developing this locally. And that inline code is going to use WebSockets to monitor and be notified of any changes that happen to your source code or your modules. So once you have Webpack Dev Server installed, you also need to add a little configuration to your Webpack config. In this case, to the output object, we'll add public path. And that's just going to be a URL where you want your assets to be hosted from. So we'll duplicate the local host, the port 8080, and we'll say I want this hosted on the subpath assets. So then if I want to consume these bundles in my HTML, I'll just make sure that my script tag now points to the Webpack Dev Server assets bundle file. So now looking at this, we're going to have a slightly different example. So inside this, I'm going to import some hobbies. And that's just going to be an array with a few items. And I'm going to use my logger module that I had before and just log out the hobbies with this for each call. And here's the hobbies. I'm literally just exporting an array with 3 items in it. So to get the server running, we got to run Webpack Dev Server, the host, port, and inline. We'll let it start up. Now we know it's serving the files. There we go. There's our hobbies printed out. And so we want to monitor and we have this update if any changes happen, so we can do that. We're going back to here. I'm going to bring up DevTools down here as well. So I'm going to change my hobbies and say maybe riding, jumping, and swimming. Hit save. Refresh, print everything out. This isn't something new, crazy, because we've seen this a lot with like gulp or grunt. We can do live reloading. But notice that Webpack Dev Server did notice something changed and it wanted to reload, and it was able to reload and get the new bundle and the new hobbies. But remember, this was a module. This wasn't our actual application code. But that's not the coolest part. So let's take that a step further and talk about what I would say is probably one of the biggest features that Webpack Dev Server offers, and the thing that I really like about it. And so if there's one thing you take out of this that could be very beneficial to you, it's this. It's hot module replacement. So we're going to modify the Webpack Dev Server a little bit and do better than just refreshing the browser when something changes. So at a high level again, the browser is going to request a file, we'll get the bundle sent down to it. But let's think about what was sent down. Remember, we still have all of our original modules in that modules array in this bundle file. So I have the log module, I have my hobbies array, and then if I'm over my text editor, and let's say I edit my hobbies, again, Webpack Dev Server is going to notice that, but in this case, it's going to create a hot swap copy of it, and then it's going to send that down to the browser. But in this whole process, all it's done is it's literally swapped out that hobbies array in my browser code, in the bundle file, without having to refresh the browser. So this is really awesome and a really useful feature. And to enable it, it's super hard. All you gotta add is this hot flag. And that's gonna add in additional runtime code that's gonna enable this hot module replacement to work. So now, if we go back to that hobbies code we saw, we'll modify it a little bit because we're gonna need to make sure it can work with hot module replacement. Now when I import the hobbies, I'm gonna call it default hobbies. And then all that code I have just for logging them out, looping over them with a for each call, I'm just going to plop that in a function called log hobbies now. And that way I can just pass in whatever I want to log out. So then at the bottom, I'll go ahead and I'll print out every hobby, what I first imported. But now I can add in this next feature with the hot module replacement. If hot module replacement is enabled, this module.hot call will pass because it's going to be an object. It's going to be truthy. If it wasn't enabled, then that would just probably be a null or undefined, so the if check would not pass. So we've enabled this, so it's going to pass. We know module.hot is enabled. So we can call module.hot.accept. And we can say, I want to accept any changes that happen to the hobbies module. And since this is JavaScript, we'll need to provide a callback when we know that something has happened to the hobbies array. And so the trick here is we just want to require the hobbies array. Notice here we're not using import syntax, and that's because that would be a syntax error if we try to use it inside of a callback. It's a static feature of ES6. And because we exported it with ES6, we also have to say .default when we require it, and that's just how ES6 exports work. But once we've required it, it's basically cleared the cache, given you the new copy of hobbies, and now we can print out those new hobbies in addition to the default ones that were just printed. So to kind of make sense of this and show you what this actually does, we'll go back and we'll look at this with hot module replacement. So we'll run the Webpack Dev Server. Actually, I forgot to provide the hot there. All right, so that's running. We'll now go to the code for that. We'll refresh over here. You see the hobbies showing up. We'll actually clear that out. We'll show that after a minute. So bring up the hobbies. I want to change them again. We said riding, jumping, and swimming. But now when I hit save, it's not going to refresh the browser. We're going to see all these hobbies get logged out underneath what's already in the browser currently, because it's going to swap out the array, and we're going to be notified of that so we can print out what just happened, what the new stuff is. So we'll hit save, and there we go. It got printed out down there below it. And if we go to look at console, we'll see that it detected something changed, but now it's saying app hot update. So it's going to check for what actually updated. It's going to see that this module, which was the array, updated. And so we know that changed. So we've accepted that change right here. And we've required it and we've logged it out. So this is the really cool feature I think Webpack Dev Server has to offer. And so to explore that a little more and see how it can be beneficial, it's really beneficial with frameworks. So it works really well with React, and I've actually gotten it to work a little with Angular 1. Now there's one caveat to all of this. When you're working with React or even Angular, you're going to have potentially state built up inside your components, your directives, what have you. And so ideally you're going to want persistent state, and you're going to want pure components. And what all that means is for pure components, if your component does a lot of asynchronous stuff, calls, when it gets reloaded, that can have unintended side effects. So you've got to be careful about that. And then the persistent state is where you would want the state to be a little separate. So this is where Redux ends up being really useful, having your state outside of your components. So if we look at this just in terms of maybe React, how this could be beneficial, and you could think about this the same with Angular. We'll just change directories and get it running. So all I have in this example is just a name tag. It displays my name and I can edit it. And I'm using Redux to store these changes. Put my son's name in there. And so what I'm going to do is I'm going to open up the component for this. And hopefully, some of us may not be React developers in here, but hopefully the JSX HTML is pretty well to follow along with. So that's all I'm going to really show is just the HTML portion here. So it's pretty straightforward. We have a header tag, and then we got our inputs for our form to update the name. Let's say I want to make some changes to my component. I don't want to lose any state I've built up and worked on. So let's say I want to add in maybe my job here. And we'll say I am a job. And we'll add an input for that. Now when I hit save, it's going to, like we saw before with the hot module enabled, we're going to re-render everything, but that's fine because we have all of our state still persistent thanks to Redux. And there we go. There we popped in that I am a programmer, and I had already had that value pre-filled, but we saw that we didn't lose the state with this jet Fairbank. If I hit refresh, we lose it because that state doesn't persist across sessions like that. And so this is really powerful with React. And I'll just show you again, there are some already built-in ways to do this with React thanks to the React hot loader. And then there are some ways to get it working with Angular 1 and definitely some libraries out there for Angular 2. So this is something I highly recommend you check out if you want to use Webpack. It can be very useful for React and Angular. So now switching gears a little, getting out of development now, let's talk about another really cool, useful feature with Webpack. And that's CSS modules. And to kind of explain what I mean by what are CSS modules, let's look at the problem we're trying to solve. So if you've done any CSS before, you may have run into some issues like this, where we have some maybe global style called highlight, and then we also have maybe a component like data grid. And that data grid may use a modifier class, also called highlight, to highlight a row. Well, what's the problem here? We're going to have a conflict where that global highlight is going to affect one thing, but it's also going to affect our data grid as well. And so we can fix these issues, obviously. We can apply things like BEM, object-oriented CSS, or SMAX, but I would contend that we're putting a lot of mental burden on ourselves that we may not necessarily need to. It'd be really awesome if we could depend on our tools to handle some of this for us, to where we're not having to learn more and more design patterns to apply to this and that. So we can do that with Webpack and CSS modules. So at a high level, what we want to do is we just want to feed in CSS now to our Webpack bundle and generate CSS out of that. So we don't have to use just JavaScript. So to get this working with your Webpack, you can install it, again, by npm. It'll be a development dependency. You'll have CSS loader and style loader. And once you have those installed, we'll just add them onto the loaders array that we saw earlier with Babel loader and ES 2015 code. And just to blow this up and explain it a little more, let's see what's going on here. So we have that test property again. Remember, that's going to be a regular expression that says, here's the type of files I want to process with this particular loader. Then we have something interesting going on here. We have some weird exclamation point question marks going on. So what's really happening here is we're actually using that CSS loader and that style loader both together. And they're gonna work in tandem to process our CSS files. So looking at that exclamation point first, the best way to think of it is sort of like a Unix pipe. And the flow here is from right to left. So our CSS will be processed with the CSS loader, and then going to the left, piped through via that exclamation point to the style loader. We also have this question mark. And all that question mark really is if you think of get parameters for a URL when you visit a website or you're building an application, we typically call that the query string. Well, that's what this question mark functions as here. And you can do these queries, these extra configurations for your loaders by an object too. I'm just showing it here with the question mark query. And all I'm telling you here then is this particular parameter modules. It means enable the CSS module spec. So overall, what all that's going to do is we can feed in our two separate CSS files. General might have that highlight or some other stuff. Data grid can have specific classes for our data grid component. CSS loader will create some raw CSS. Style loader will then create a style tag and append it to the head element of your HTML document. But in this whole process, it's going to mangle your class names. And the purpose of that is that you don't run into these clashes anymore between some style in one module and styles in another module. And the name it picks, how it mangles it, it's just based off a hash of the CSS file itself. So what that means then is now we can import CSS in our JavaScript code thanks to the CSS loader and the style loader with Webpack. Notice here I'm going to explicitly say styles.css. That way it knows to use the CSS loader and the style loader. And it's actually going to give me back an object. That object will contain all of the class names that we might have defined in our CSS style sheet. and then also give us whatever the mangled version of that is so we can use it in our application code. So to make sense of all that and what it actually looks like, let's look at another example. Start up the dev server. So we have our name tag component that we saw earlier. But notice now here at the top, I'm actually importing that style sheet now. If I go over to it, I have a name tag class right here. And the usual convention you'll use with CSS modules is to actually use camel case, because in the end it's not going to matter, it's still going to mangle these class names. But when I import here styles from the relative path to this style sheet, I'm going to get back an object, and I can say styles.nameTag, like we have right here. And it's just going to be a key value here, so nameTag is going to refer to some random hash string that it computed for that particular class name. So what's beneficial about that is I can go down now in my React component here, and I can provide that class name by style. So I'm using what I know it's called, name tag. I don't care what the hash version is. We've saved that, we don't see anything right now, but it should be set up over here now. And just as Webpack monitors all of your JavaScript modules, it's also going to monitor your style sheets. And it can use hot module replacement to update styles. So I'll change some state here. And let's say now I want the background to be black, the color to be white. Or green, sorry. And there, it updates automatically. The state is still persistent. We used hot module replacement to update the style sheet. You can fix it a little more. Add some padding, change the font, maybe add in a little greater than sign like terminal input. But to show you what's happening under the hood, go to the head tag here, and notice here, it's appended this style tag. And there's all the styles we wrote, but they don't say name tag now. They show this hashed version. And if we go down to our component, right here is where I added that styles.name tag. But notice again, it's using that mangled version, the hashed class name there. So this allows us to keep our CSS very modular, incorporate it in our Webpack bundles, and avoid a lot of these name clashes, so we don't have to learn lots of esoteric rules or frameworks for writing our CSS. That doesn't necessarily mean we don't need to still have good organization with our CSS, but this is a really beneficial tool to utilize. So we've been talking a lot about development and cool features, but when it comes to Webpack at the end of the day, we still need to ship something. So the last thing I want to cover as we wrap up is, once we've done all these features with Webpack, ES6 code, CSS, how do we actually get something that we can send over to a production server? So the basic idea is, in this case, we do want to have two separate configuration files. We'll have a Webpack Dev config and a Webpack Prod config. They'll both take the same entry, but the output will be vastly different. We've already seen what the output looks like, a lot of the examples we've seen prior, but in production we know we prefer for it to be obfuscated, minimized, pinned a hash fingerprint so we can make sure it gets cached properly, etc. So let's walk through how you can get a production configuration set up and produce production files. So the primary way that you're going to approach this is we're going to add one more configuration object to the config. That's a plugins array. And we'll define multiple plugins that handle different pieces of the equation to produce production-worthy code. So the first one we're going to look at is the define plugin. So the define plugin, you can kind of think of it as, if you've ever done some C programming, C++, where we can create macros via define, it's something that we're going to replace in our code. And we'll see examples of what I mean by that with JavaScript code. But basically, this is useful for if I need to have some debugging code in my development environment, or maybe in my production environment, I want to have some performance enhancements that are only enabled in production. Additionally, I could add feature flags and try out certain features in different demographics or A/B testing, whatnot. So to configure it, we're adding one new thing. We need to require a Webpack inside of our config, and then we instantiate that defined plugin inside of a plugins array. And all the defined plugin takes is a key value pair. The keys are identifiers. And it's going to know when it encounters an identifier, like a variable, or in this first example, a path from process to env to no env. Webpack's going to know to just replace that with whatever the value is. So you see here with no env, I'm replacing that with production in my production environment. That makes sense. Which also means my helper underscore dev, I want it to be false. And then if I had a feature flag that I'm not ready to put in production, I could say new feature false. And then likewise, if we look at the bottom, we do something different with our development environment. The node environment's development, and then dev and new feature are true. So if this was encountered in real code, what Webpack actually does is instead of evaluating like it looks right now at runtime, it's going to go through and replace all this. So in a production environment, all of these are going to just be if false, so it's never going to run. And that way we avoid this being included in our production environment. So the next plugin is a way for us to actually, so far we've been talking a lot about just throwing everything together in one bundle. But there may be instances where we want to split out some things, especially shared modules. And that's what we can use the Commons Chunk plugin for. So let me illustrate the problem here. Let's say we have a bunch of dependencies, third-party libraries, along with our application code. We built this fingerprint production file, gets served to the browser, that's fine. But remember, this bundle, this production file that the browser has all of those vendor files included in it. What happens if I go in and I edit my application? I haven't touched my dependencies. I haven't touched React, jQuery, none of those. I've still produced a new bundle. The production file gets sent down. That production file still has all those dependencies, but none of those dependencies change. So I basically penalized the browser because it had cached my file. Now it has to grab a new version, which means it's had to include all those dependencies again, which just bloated the file size. So ideally, I'd like to change this a little to where I have two fingerprinted files. I have my main file, and I have a vendor file. Those get sit down separately. And remember, the vendor file will have all of my vendors, jQuery, React, etc. So then when I go in and edit my application, again, I haven't touched many of my dependencies. I haven't updated them. I produce a new bundle. It's got a new hash. But now, that's all I have to send down, just my application code. That vendor file can still remain cached because nothing has changed. And so this helps improve performance in a production environment. So the way to do this is to modify our configuration a little. We'll use an entry object again. We'll have our main pointing to our main.js. And then we're going to have this vendor object. And it's going to point to any third-party dependencies I want to split out and make a shared bundle, in this case like a vendor file. And then down here I'm also going to modify the output file name, and in addition to that bracketed name, I'm going to have a bracketed chunk hash. So chunk hash is another special variable that Webpack understands, and that means it's going to take a hash of the particular chunk. So that sounds kind of confusing, so think of main.js as one chunk, and vendor as another chunk. So ideally, when I fingerprint these files, I want a hash of main to only refer to main, and I want a hash of vendor to only refer to vendor. And that's why I'll use a chunk hash here. If I use just hash, then it would use a shared hash, and that would defeat the purpose of trying to cache the vendor file separately. Then finally, I'll instantiate that Commons Chunk plugin. The first parameter just refers to whatever we called our vendor inside the entry object. In this case, we just called it vendor. And then finally, we give it a file name. And again, we want to use chunk hash here so that it's separate from our application code. It can be cached separately. And so that's the way we can kind of split these out and make sure we can get better performance, especially when it comes to browser caching in production. So another thing is including this ExtractText plugin. And so let's return back to the CSS real quick. You might have been wondering about this. We were appending a style tag to our HTML. That's probably not a good idea in production. Ideally, we'd prefer a separate style sheet that, again, can be cached separately by the browser. So we can actually do that as well with Webpack. So instead of the style tag, we just want to have a CSS file that's also fingerprinted for caching purposes. So the way to do that is we just install the ExtractText Webpack plugin. And then inside of our config, we'll modify it. We'll require the plugin. And down in our loader we used to have, and remember this is for the production environment, we want to call ExtractText plugin.extract. And we'll provide the modules, style loader, CSS loader, as separate arguments. And then down in the plugin, we'll instantiate it. We'll give it a file name, main, and we'll use the chunk hash again, .css. Finally, as we know with production, we would like to obfuscate and minify our JavaScript. And so there's something already built in with Webpack, that's the uglify.js plugin. We can provide the minimize option. So we're probably all kind of familiar with minimizing and obfuscating, so we kind of understand the benefits of this already. There is one slight additional benefit. Back when we had defined plugin, where we were providing feature flags and debugging constants, remember they became, in our code, the bundled code just is if false. That's dead code, it's not going to run. So actually there's no point even including it, because it's just going to be file size below. Well, when we include the uglify.js plugin with minimize true, it's actually going to detect any dead code in our bundled code and just remove it, therefore reducing the file size. So as we begin to wrap up, I just want to provide you some resources. Webpack.github.io, that's where you can see a lot of the documentation for Webpack. There's lots of configuration available, a lot more than I was able to even cover today. And then some GitHub links for some of the hot loading. And again, these slides will be available online too. So I also at the bottom provide a couple other alternatives if you're interested in looking into them. There's Browserify, which does something similar to Webpack. It's not as configurable, so you'll have to install multiple plugins to get it to work kind of like Webpack. There's also Rollup.js, which is pretty powerful actually. It uses something called tree shaking. That's something I wasn't able to cover today, but it's something that will be included in Webpack too. But at a high level, what tree shaking is it can detect unused code as far as what you're importing. If you have a module that exports maybe two functions, like my math module that had an add function and a multiply function, if I never use the multiply function anywhere in my code, then Rollup or Webpack 2 can detect that and not even include it in the final bundle. So that's another useful feature for cutting down file size. So with all of that, I hope you all are geared and ready to maybe try out Webpack, some of the cool features, and bundle together your files. So thank you so much.